Today I want to tell you about the modern data stack is dead and who killed it. We read this blog post a couple weeks ago and I want to tell you about it. What we're saying is that this poor old data stack, it got murdered in cold blood. For years, data teams have relied on patchwork of tools. They had ETL pipeline, they've had warehouse orchestration layers and dashboard. But getting anything done has meant that usually you've had to switch between 4 or 5 systems just to move into transform data. Something changed. The modern data stack, it wasn't killed by a single project or a company. It was killed by a bunch of different projects, an entire ecosystem. So what we did is we rounded up the suspects to see. The first suspect is the AI code editor. This is the one that has the most blood on its hand. This is the one that's easiest to blame for everything with Claude Code, Codex, Cursor, all of that. It's radically changing how people write code, how people are processing data. It would be all too easy to blame AI and throw the baby with the AI bathwater and say AI is the one that did everything. For example, me, I actually really started using SQL and DuckDB because we added AI about a year ago into Fuse, and I was able to say, hey, if this is the query that I want to do, show me how to do it. I don't know how to write it. I can tell you if the output is correct or not. So AI is drastically changing everything. We're also building tools for AI much better. We mentioned it down the line here. We've added things like LLM TXT. Our docs are now written directly for AI. We're telling some of our customers and partners that their data needs to be accessible by AI. But it would be all too easy to point the fingers just at AI. Instead, we have another suspect, which is S3 and Parquet. The reason why is that cloud storage in general and Parquet files work hand in hand so flawlessly at being able to aggregate so much data, and they work natively with tools like Pandas, DuckDB, all of that. All of these tools allow you to manipulate a lot of files, store them directly on the cloud as Parquet files, and then if you index them properly and if you organize them properly, you basically have a whole bunch. You can have like terabytes of data that it's just stored as individual Parquet files on S3. And like there's a project that we did here where this is the USDA crop data layer for the entire United States that we just converted to H3 hexagons for clever partitioning, and it's just stored in Parquet files directly on S3. And that means that that's the way that we can store the data. We don't need anything complicated. It's just all these open formats. The next suspect is DuckDB, the good old Duck. It's an open source in-process analytic database management system, if you're not familiar. And what it allows you to do is it allows you to write SQL against a whole bunch of the aforementioned S3 and Parquet files. So I can have something like this where I just say, hey, read this whole big giant list of Parquet files where my ID is right there. This is something that we've done with the Overture Maps Foundation, where we said they have these IDs for buildings across the entire world, and I can search for just one building across huge data sets. Here every file is there's 50 gigabytes of Parquet files, and I can just say, well, just by writing here in DuckDB, and this allows me to query all of that data. I can make like much more complicated query, things that I wouldn't be able to do with Pandas directly. Like in memory, it's much more efficient. There's always this race between these two projects, and then on top of that you add LLMs that are able to write these queries very efficiently. It makes a very compelling case for why you might not need a lot of these very complicated modern data stack. Other suspect that we have is serverless compute. Serverless compute is the idea that you don't need to have a big server that's always on to run. You can have these smaller nodes that just turn on and off whenever you need them, and then they can scale up and down depending on your needs. So if you need to access all the data that you have, you can just spin up a lot of these instances up, and then when it's done, you just shut them down. We think that these are all the suspects. And what we're saying is actually, it's probably all of them. It's probably all of these suspects all together that killed the modern data stacks. It's when you combine them together. It's when you bring the AI editor together with the cloud and Parquet files, with things like DuckDB, and then serverless. You can build very big data infrastructure with just these things without requiring a lot of these very complicated tools. You can bring in your data very easily with DuckDB. You can convert it to Parquet very easily. You can bring it all together like that. And so what do we think we should do? There's multiple approaches that you can come here. The first is to give Claude Code basically everything. Just dump everything in Claude Code, give it all the credentials, give it everything, and say, you figure it out. The other one is to say that's probably not a very good idea. It's what we're saying here, this approach too. It's giving Claude Code an easy access to scoped processing. It's saying maybe there's another place where the environment variables are stored and where you just have access to the data, but you can't change the permission. You have access to the compute, but you can't do just anything. You can scale up the compute up and down with some easy tools, but that's it. You have these sandboxed environments. That's very important to be able to make sure that Claude doesn't completely nuke all of your projects as well. Now, the problem is to be able to have that, now you need to handle infra layer, you need to handle auth, you need to manage permissions, all of that. And so that's why we've been building Fuse. It's built on Python because that's where a lot of the data science and data manipulation happens. If your files are on S3, Snowflake, Google Drive, if it's a PDF, you can work with it in Python, and LLMs are great at writing Python. We also have scalable serverless compute. Like spinning up an instance in a job should just be a few lines of code. So what we have here is just a very simple code snippet where I have how to open a Parquet file. And then this is the code snippet for just loading, running a process and then running it in parallel with this .map function. And I can run it over 500 workers in parallel here. This is a visual of like how we're able to basically say, hey, I have a function. As long as I can make that run, do one process with just udf.map, I can run that over hundreds of workers and just scale that to hundreds and thousands of workers at the same time. That means that you can write simple operations and then scale them up very, very easily. What we're seeing is that AI is writing the code. Even at Fuse, we aren't writing code anymore, or barely. We're getting to a place where we're not going to be writing code at all anymore. That open formats, they're making it very easy to work with really, really large data sets. Serverless is removing the need for infrastructure. We just need a way to do that reliably, and that's what we are thinking about doing at Fuse. That's why we think that the poor old data stack got killed, and these are the suspects. They're all in it, but this is the reality of the world. If you want to try out Fuse, see a little bit more, you can go to fuse.io/workbench. You can read the docs or ask Claude what Fuse is, what you can start building. It can write functions in Fuse for you and deploy them very easily. There's going to be a link to the blog post if you want to read it. Until then, looking forward to seeing you next time.